All right, ladies and gentlemen, let's get into factoring when a is not equal to 1. This one's gonna be fun. And what I'm gonna do, because I really want to share with you all of much knowledge as I possibly can, I am going to go through 3 different techniques that you can follow. This is gonna probably actually give me the most advanced, the most helpful, and the one I'd rather you focus in on. However, we know that once things kind of get a little bit more confusing, we start dealing with bigger numbers, we kind of want to follow a algorithm or some kind of step-by-step method. But the reason why I start with this one is because, you know, as teachers, sometimes we like to get confusing, more confusing than we really need to be. And while I think it's important for you to know how to factor when a is not equal to 1, the reality is that majority of the factoring when a is not equal to 1 that you're going to be like providing, or at least I see in calculus and for even from upper level mathematics, is going to be stuff you can do in your head. It's not going to be crazy numbers. But for whatever reason, we like to torture sometimes students. I apologize for that, being a teacher myself, with some more difficult examples. But in reality, guys, what we talked about last video, or what I wanted you to see, the middle term is all about combining those 2 squares, right? If you remember when I had that first example up here, the middle term is all about the combining. So we're not really gonna be focused with that. What we're gonna be focused with is the first and the last 2 numbers. And one thing I want you to be able to understand is that when you're factoring a quadratic trinomial, we know it's going to be factored into a product of 2 binomials. So a lot of the stuff we can do in our head. Majority of the problems that you're gonna get in your class, you can do in your head. It takes a little practice, I understand that, but I'm gonna have some examples, practice problems for you down below. Majority of them are gonna be relatively simple because I want you to get familiar with doing the simple stuff rather than trying to memorize these long algorithm step-by-step examples of doing these 2. But whatever works for you, stay with it. I always tell students, whatever you know how to do, then do that, right? But when you have something that's timed, like a final exam, SAT, ACT, you want to make sure you can do things efficiently. So, rambling on, sorry. All right, so I know that my first 2 terms that I multiply, remember we're doing reverse FOIL, is going to give me a 2x squared. Well, keeping with integers, I know that has to be a 2x and an x, right? We're not doing rocket science here. And then to give me a -1, I know my 2 numbers that I'm going to multiply are going to give me -1. What are my options? 1 and -1, right? I don't have any other crazy options to go with here. So one of them has to be 1, one has to be -1, or 1 and -1. Which one is it? Well, what you need to do is look at the combination of your middle and your last terms, because the inner and your outer, sorry, I should probably use that terminology, the inner and the outer are going to be what combined to give you this x. So since my x is positive, if I do a 2x times a +1, that gives me a 2x. And if I did an x times a -1, because remember, -1 times 1 has to give me -1, but you can notice that these 2 combine to give you my middle term. -x plus 2x is gonna give me a +x. Voila, this is all the math I'd be doing in my head. I'd probably do this problem in 30 seconds, but I just over-explained it for an extra minute, right? So that is one I could do in my head, and that is the process that I do a lot of times for a problem like here. You could break this up into a 4x, and a x, and a 2x, and a 2x, right? And then you start thinking of, all right, what 2 numbers multiply to give me -15, and start doing some multiplication with your outer and your inner to be able to see what's gonna line up to give you a -7x. It takes practice, and I know a lot of you don't like practice, a lot of you don't like to do the mental math, but I'm telling you, it doesn't take much for you to start being able to realize and start seeing the patterns and having that foundation with a strong number sense, which we started this course on, that you start to get more comfortable. But let's say you're like, Mr. McLogan, I just need some solid tips to be able to factor. I don't want to be able to do this stuff in my head. I don't want to be able to do it quickly. I just need to know how to get the right answer because I don't have a calculator or a phone when I'm taking a test. Here's a couple methods we could do. The first one is going to be what we call the AC method. So what you're going to do is you're going to take your A and your C, that is your first, the coefficient of your x squared, and your constant, you're going to multiply them. 4 times -10 is going to give me a -60. Then what you're going to do is going to take your middle term, which would be our B, and you're going to write it right here. Now what we need to do is identify what 2 numbers multiply to give me a -60 and add to give me a 7. Now you might be saying, whoa, 60 is a big number, has a lot of factors in it, right? So why don't we ignore the 60 for a second, and let's just do that mental math of what numbers multiply to give us 60. So we have 60 times 1, right? That's even, so I could kind of divide by 2. I have 30 times 2, I can divide by 2 again. 15 times 4, a lot of students don't get this, but we know 60 divisible by 5, so 12 times 5, and then of course we have a 10 times 6. All right, now again, remember though, this is a negative. That means one of these factors has to be negative, right? One's negative, the other's positive, or one's negative, the other one's positive. So again, in reality, rather than worrying about which one's negative, just see which ones have a difference of 7. You can see 12 and 5, all right? 12 and 5 have a difference of 7. Now, do we want negative 12 and 5? Do those add to negative 7? Or does negative 5 and positive 12 add to negative 7? Hopefully you're like, dude, come on, this is easy. It's negative 12 and a positive 5. Okay, so now what do we do with this work? Well, there's 2 different things we can do. And unfortunately, I am a teacher. I have to show you both ways. So I'm gonna show you the box method because that was the way that I instructed or kind of taught throughout this course. And then I'll show you another way that I also instructed throughout this course. So the first way, these are what we call our middle terms. These are gonna be what combine to give us a negative 7x, right? So if I create a box, just like I did in my previous videos, I could say, here's a 4x squared, here's a negative 15, and these are gonna be my 2 middle terms. So negative 12x and a 5x, right? Remember, they are the linear terms. These combine to give me that negative 7x. That's why I added an x with them. So you say, well, Mr. McLogan, 4x, that could be 2 times 2, 2x times 2x, or it could be 4x times 8x. You are correct. However, if I put a 2 here, 2 or 2x, 2x times what gives me 5x? That's gonna be a fraction. I don't want to do that. And I don't want to use a 4 either, right? But I could use an x, and then if that's an x, that means that's a 4x. X times what gives me a 5x? Positive 5. 4x times what gives me negative 12x? Negative 3. Ladies and gentlemen, that is going to be my answer right there. It's a 4x plus 5 times an x minus 3, right? Because remember, factoring is the process of finding the sides of your rectangle. However, there is one more thing I want you to recognize. Remember, I taught this before, and I think we'll have enough room. These are your middle terms that combine to give you that negative 7x. So you could also rewrite everything like this: 4x squared minus 12x plus 5x minus 15, right? We're just rewriting the expression. And then you could group the first 2 terms and factor out the GCF. What does a 4x squared and a negative 12x squared have in common, right? The GCF, they have a 4x in common. So you factor out a 4x, you're going to be left with a x minus 3. Over here, you can factor out a 5, you're left with an x minus 3. And voila, ladies and gentlemen, when you factor out the x minus 3, again, you're left with a 4x plus 5 times x minus 3. Now, that was a way that I taught a lot of my students because it related to what we learned it worked the way that I taught factoring. So it worked within the classroom. A lot of times this is the way they learned it in Algebra 1, Algebra 2. So if I was teaching it in maybe, pre-calculus or calculus, this is a way that I could help students solve the more complicated problems, the problems they couldn't do in their head. But there's also another way that we can do it that's a little bit simpler, a little bit faster, doesn't relate to as much, but I think you might enjoy it. So how about this? Right? I don't really want to break this down into 6 times 1, 3 times 2. That's a lot. So I could do the same thing, the AC method, and I could do 6 times 4 is going to be a positive 24. So we get the 24. Let's do 24. Okay, and then we take our 11. So we say, all right, what 2 numbers multiply to give me 24 and give me 11? I don't know, I still like writing things out for you guys. So we have 24. That could be a 24 times 1. We could do a 12 times 2. We could do an 8 times 3, and we could do a 6 times 4. Now, since my middle term is positive, that means both of my factors have to be positive, right? If they're gonna add, then they can't, if you had a negative plus a negative, that would still be negative. So since we're multiplying to give me a positive 24, but add to give me 11, they both have to be positive. And hopefully you see what 2 numbers multiply to give me 24, but add to give me 11, that's gonna be an 8 and a 3. So what we're simply going to do is I'm just gonna write it in factored form because we know it's a product of 2 binomials of x plus 8 times a x plus 3. But now, notice, ladies and gentlemen, that took the 6 times the 4. So if I wanted to go back and see, well, what would my factored form? I need to divide by a 6. But I'm only going to divide by that second term. Then I'm going to reduce the fractions. So that gives me x plus a 4/3 times a x plus a 1/2. Now, we don't really want to be dealing with fractions. We know that this times this does not equal a 6x squared plus 11x plus 4, right? So if you think about when you are solving quadratics, I can rewrite this. I can multiply back this 3 to get it off the denominator, and that will give me my final answer of a 3x plus 4 times a 2x plus 1. And remember the golden rule that I talked about, guys? If you're unsure, you're like, I don't know if I did that correctly, Mr. McLogan, multiply it back. 3x times 2x is a 6x squared. 3x times 1 is going to be a 3x. 4 times 2 is going to be a positive 8x. 4 times 1 is a positive 4. Add the middle terms, you get an 11x. You can see I'm doing my math right. All right, now last two examples. The video doesn't have that much longer, guys, because the last two examples are those relationships, right? This can be hard to do in your head. This can take a lot of time if you're doing it that way or that time. This is a cool little trick, but sometimes if you don't have a foundational understanding of why and how you're doing it, it's easy to forget. So always look for patterns, right? Now, a lot of times students will see, ooh, I can factor out a 4 of the 4 and the 20. Ah, crap, but not the 25. So don't try factoring out a 4. Ooh, I do recognize 4 is a square number. 25 is a square number. It could be a perfect square trinomial. Now, before you write it as a perfect square trinomial, I would recommend writing it in factored form to double check it first. So to look at it as a perfect square trinomial, say, all right, what is the square root, right, of 4x squared? Well, that's going to be a 2x. And since this is middle term's positive, then I know that has to be positive. Square root of 25 is going to be a 5. So is it 2x plus 5 times 2x plus 5? Well, 2x times 2x is a 4x squared, yes. 5 times 5 is 25, good. 2x times 5 is 10x. 2x times 5 is a 10x. 10x plus 10x is going to be a 20x. I forgot the x, sorry about that. So you can see we can rewrite this in factored form of a 2x plus 5 quantity squared. All right, last but not least, you can see here, it's a binomial, automatically binomial. It's like two options, factor out the GCF or difference of two squares. And again, I recognize here, my first term, or this first term here is a square number and a square variable, and this is a square number. But again, since there's only two of them, I can recognize, is it gonna follow the form of a minus b times a plus b? So again, saying this, what number multiplied by itself is gonna give me 81? That's how I got the 2 over there. Well, that's gonna be 9. What number multiplied by itself gives me x squared? That's x, right? And then 10, what two numbers multiply to give me a negative 10 but add to give me 0? Well, that has to be a negative 10 and a positive 10. 9x minus 10 and 9x plus 10. Voila. And there it is in your factored form. Now, ladies and gentlemen, we have covered everything from our factors, or from factoring, from the very basic to understanding, to factoring trinomials, factoring binomials, to even factoring when a is not equal to 1. And I feel like once you guys get your practice done and you check your understanding, you're gonna have a good foundation. But the reality is there's still gonna be some problems that are gonna trick you. They're gonna mess you up. That's why I wanted to include one more video for those of you that kind of want a little bit more of a challenge, or to just make sure that your teacher is not gonna confuse you when you have to be assessed on your own. So if you're ready for that video, get some practice, work on these, but then go ahead and check out the factoring with fractions.